Okay, good morning everybody. I think we might just get started while other people are starting to join the seminar. Welcome to today's JKMRC Friday seminar series for Friday the 12th of June. My name is Nathan Fox from the W.H. Bryan Mining and Geology Research Centre at the University of Queensland. Online we have Professor Rick Valenta, who is the Director of the W.H. Bryan Mining and Geology Research Centre and also currently the Acting Director of the JKMRC. Rick's going to help towards the end to help moderate questions from the audiences. But thank you everybody online for joining us. Before we begin, on behalf of the SMI and the University of Queensland, which is based here in Brisbane, we would first like to acknowledge the traditional owners of the lands on which we meet today, and we pay our respects to their ancestors and their descendants. Today it's a pleasure to introduce today's speaker, Dr Helen Degeling from the Geological Survey of Queensland and the Department of Natural Resources, Mines and Energy. Helen is the Director of the Minerals Geosciences for the Geological Survey of Queensland, and she has a diverse experience and background, commencing with research at the ANU and the University of Calgary, studying various aspects of geochemistry, geochronology and thermodynamics and metamorphic terrains during her PhD. Following that, Helen got 12 years experience working in gold and base metal exploration throughout Australia and South America. This includes the Pilbara, Yilgarn and Gawler Cratons, Mount Isa and the Lachlan Fold Belt. In 2018, Helen joined GSQ as the Director of the Resources, and today Helen is going to introduce the importance of new economy minerals to Queensland and the steps the government has taken to boost exploration for these vital and strategic commodities. Helen's talk is titled GSQ's New Economy Minerals Initiative, Geoscience for a Technology-Driven Future, and it's going to be a very exciting talk. Before we begin, I'd just like to ask people online if you can ask questions in the Q&A box on Zoom, on Zoom, that would be great, and then we can direct those towards Helen towards the end. So without further ado, I'd like to hand over to Helen. Thank you.
Thanks, Nathan. And I'd really like to thank you and Rick and the JKMR for inviting me to speak today. I'm very excited to share with you the initiative that we've set up, a new initiative by the Queensland Government to promote exploration for and the development of critical or new economy minerals. But first, I'm going to do a little scene setting. The Geological Survey of Queensland's role has traditionally been one of data custodian and provider of pre-competitive data for mineral and other commodities exploration. We do this with the goal of supporting industry to make new discoveries in Queensland, and industry success really is our reason for being. We do this in a number of ways. As custodians of the state's geoscientific data, so that what's been done before is available to inform future success. We do this as providers of pre-competitive data, geophysical surveys, geological mapping, geochemistry. And we also conduct mineral systems studies. It's easier to find new big things when you understand where they might form and what the smoke for these systems looks like. We also help by supporting innovative greenfields exploration through our grants scheme, the Collaborative Exploration Initiative. So in a nutshell, we do the jobs that are too big, too hard, or too expensive for any one company to undertake, but are vital for the success of the minerals industry overall. To be effective in our role at the survey, we also need to understand the industry that we represent. And I speak now specifically to minerals rather than all of the other resources such as oil, gas and coal. What are Queensland's mineral strengths? Copper, of course, zinc, lead. We hold our own in gold. We lead the way with bauxite. We also have a world-class vanadium field near Julia Creek, and we have some of the highest grade graphite in the world, not to mention cobalt. And there are many more examples I could mention: tin, tungsten, silver, rhenium, the list goes on. An important fact to recognise is that our sector is overwhelmingly dominated by juniors, as is the rest of Australia. This map shows just how much of Queensland's mineral exploration tenure is held by junior companies, which are in purple. This data is from October 2019, so it's not out of date. This amounts to nearly 80% of ground being explored by companies with the smallest budgets. And it is these companies that rely the most on government support and joint ventures with larger organisations to secure an injection of funds with which to conduct exploration and make new discoveries. Of the challenges facing mineral exploration, cover remains one of the biggest. How do we see through the thick blanket? Our mineral endowment in outcropping areas, which are shown in grey, is fantastic. And you can see the black dots on this map represent mineral occurrences. Imagine, as I know that some of you have, what we might find hidden away under all of the dirt, which is represented in green. This is a similar map showing the distribution of exploration tenure relative to outcrop. The close association of tenure, shown by the blue boxes, with the grey outcropping areas clearly shows how difficult it is to explore effectively under cover, particularly deep cover. A few brave souls are having a go, such as Anglo-American down here, but not many. This is one of the areas where the Geological Survey has a clear and strong role in providing as much data as possible in areas of high potential but thick cover, such as where the Mount Isa inlier disappears under the surrounding basins. We do this, of course, through regional geophysical surveys, geochemistry, geological mapping, and anything else really that we think might be useful. But let us focus now specifically on critical minerals, or new economy minerals, as my department likes to call them. Why are critical minerals important? And what on earth is the new economy? New economy minerals is an umbrella term for the range of commodities required in the development and construction of many low emission and renewable energy products, such as solar panels, batteries, and electric cars, and a range of other high-tech applications, including information technology, medicine, and defence. The rapid evolution of these emerging technologies is resulting in an ever-increasing demand for these new economy minerals that currently outstrips known global supply. The growing importance of these minerals and the currently limited sources of supply have led a number of countries, including the US, to group them as critical minerals, for which strategic action is required to secure predictable supplies. This drive to renewable energy and advanced technology, creating a new economy, is changing the way we explore for, produce, recycle, and use these particular critical minerals. However, many minerals are considered critical not only because of a paucity of supply, but also due to geopolitical factors. When one country controls the majority of supply of a particular commodity, oil in the Middle East springs to mind, but the example I've shown here is rare earths. Global prices can be controlled to the benefit of the supplier, political tensions arise, trade wars ensue, and in general, not many good things happen. This is just as true of key critical minerals such as the rare earths and cobalt. For rare earths, around 80% of the world's supply comes from China, as shown on this graph in red. This is an issue for some countries such as the US, who rely on rare earth imports for various defence applications. Obviously, it's not a great idea to be dependent on someone in that regard when you're not necessarily political allies. Similarly, for cobalt, much of the world's supply is from the Congo. This is a vital component of lithium-ion batteries powering the new generation of electric vehicles. But as you can see in this headline, at what cost? In the last year or so, Australia has pushed for global recognition as a secure and ethical supplier of critical minerals. In November last year, the Australian Prime Minister, Scott Morrison, signed a deal with the US President for supply of Australian rare earths and other commodities to the US. That agreement also includes a formal research relationship between the geoscience agencies Geoscience Australia and the US Geological Survey. Just last week, Another agreement was reached between the Australian and Indian governments. In this case, cobalt was singled out as being crucial, given India's Made in India policy for homegrown manufacturing, combined with its goal of full electric mobility by 2030. Cobalt, of course, being a key component of lithium-ion batteries used in electric vehicles, as I said before. Lithium and rare earths were also identified as key commodities. However, cobalt is the one specifically of interest for Queensland, and I'll come to that shortly. So as we've just seen, much of the resources discussion in political circles currently focuses on resources security and criticality. As I said before, those minerals that we call critical are the commodities for which the future demand is predicted to outstrip current supply. This issue really goes beyond markets and metal prices. It becomes a political issue that demands government response. The Queensland government's response, amongst others, has been to deliver the New Economy Minerals Initiative. This initiative was announced last year in November to include $13.8 million over 5 years from 2020 to 2025 and brings our total funding from 2017 to 2025 to be in excess of $40 million, including our previous program, the Strategic Resources Exploration Program. The funding applies to new economy or critical minerals through a broad corridor from Mount Isa to Townsville. And this funding is broken into two main streams. The first aims to expand on what we already know and maximise what we already have. It will include activities such as the reanalysis of existing core, much of which was only ever assayed for a limited suite of elements, and certainly not things such as the rare earths. We will apply the same principle to our old and existing mine sites with a tailings sampling program underway in collaboration with Anita Parbarker-Fox here at UQ, examining the concept of secondary prospectivity for critical minerals in mine tailings and waste stockpiles. The second stream is more focused on supporting exploration for new mineralisation through pre-competitive data acquisition and research. A new round of the Collaborative Exploration Initiative falls under this stream, which is the government's grant program directly for industry. One of the points of distinction between this and other more traditional funding packages managed by the GSQ is the inclusion of a dedicated research block to examine the processing and extraction of critical minerals, particularly rare earths. This is an area of significant cost and uncertainty, which I believe strongly and adversely affects industry's appetite to explore for these minerals and, of course, to produce them. If we can help to remove some of that uncertainty, the entire supply chain will benefit. This is another of our flagship research projects and is being carried out right here at UQ with a consortium of researchers from the Sustainable Minerals Institute, the School of Chemical Engineering, and the School of Earth Sciences. So we know what we mean by critical or new economy minerals, but which ones are they? Which metals and elements are the ones that will be the most affected by continuing advances in technology, including green energy technology? Copper is an obvious one and is a metal that has been mined for thousands of years. Silver is another one that we've mined for millennia. However, the box of new economy minerals also includes non-traditional but recently much discussed metals such as the rare earths, cobalt, and lithium. Then there are others such as indium, gallium, and germanium. The market for these isn't large at the moment, prices are not reliable, and appetite in the exploration industry isn't huge. However, with growing downstream demand, that appetite will grow. And through the work that we are carrying out over the next few years, Queensland will be well placed to respond when the time comes. Through the New Economy Minerals Initiative, we intend to focus our work in those areas with the greatest uncertainties. So whilst copper, for example, is definitely a new economy mineral, we are focusing a lot of effort on base metals through our Northwest Minerals Province program already. Rather, we will seek to improve our understanding and knowledge of the other commodities which have been ignored for most of history. This slide does show in green on the right the minerals for which we have existing defined resources in Queensland. As you can see, we are already well placed to meet future trends. I found this graphic recently, and I do apologise to whoever made it because I couldn't find the source in the image. Nevertheless, it is extremely useful, showing the increasing demand for a range of commodities in response to growth of low carbon technologies in the world's energy production. This graphic ignores similar demands on the same commodities driven by growth in other technologies such as phones, computers, screens, defence, medicine, and many more. So if anything, it is an underestimate of future demands. The red boxes show those resources present in Queensland, and with the exception of lithium, we are well placed to respond. The important thing is that we're not actually producing many of these metals. We know we have some in the ground, but it is important that exploration and resource development commence now to put us in the ideal position in years to come. So in Queensland, we have advanced cobalt, vanadium, graphite and nickel projects. We also have strong potential to expand the production of molybdenum, scandium and tungsten. We have known rare earth resources that are ripe for development and a strong pipeline of greenfields projects. Under the New Economy Minerals Initiative, we have developed a package of work that is truly results driven and will produce meaningful outcomes for the resources sector, not just in Queensland. Exploration for and extraction of critical minerals is a relatively new and rapidly evolving field. We have some of the brightest minds in the country contributing to solutions for the future of our sector, and many of them are right here at UQ. It is very true that many brains are better than a few, and this is a collaborative program. Much of that collaboration will be directly with industry as well as researchers. We want to ensure that we're asking the right questions, doing the right work to reach the right solutions. And the first body of work under package 1 was all about understanding what we already know and what we already have that maybe we missed. So let's look at some of the commodities that were on that future demands list, and in particular, the ones that Queensland shows great promise for. That will then allow me to highlight some of the projects that we have commenced under the New Economy Minerals Initiative. I'm going to skip lithium and move straight to cobalt, though I know we do have a few lithium occurrences in Queensland. However, cobalt is a metal for which Queensland is in a great position to contribute to global supply. There are a number of advanced projects in Queensland for cobalt, such as Scony and Walford Creek. Scony, of course, is a lateritic ore derived from weathering of ultramafics near Townsville, whereas Walford Creek, by comparison, is a sulphide ore body a long way north of Mount Isa. Both of these projects are at the stage of looking for finance to commence production. Scony contains nickel and scandium, as well as cobalt. In the northwest, Walford Creek's polymetallic mineralisation includes copper, lead, zinc and silver, as well as cobalt. It forms the highest grade sulphide cobalt resource in Australia. But none of that is work that the Geological Survey of Queensland can take credit for. Not that we aren't proud of these Queensland success stories. So what about the more speculative projects? What do we know about cobalt elsewhere, and what is the work that we in the survey and our collaborators can do to support or promote ongoing exploration? We know, for instance, that copper in the Northwest Minerals Province, not just at Walford Creek, often contains associated cobalt. The Mount Isa ore body, for example, contains up to 9% cobalt in some places. We've all seen reports in the media, perhaps, about Capricorn Copper looking at cobalt in their deposits and in their tailings at the old gunpowder mine. One of the survey's project streams, Mine the Core, seeks to fill in the gaps in our understanding of this relationship. Not all historical explorers included cobalt in their analytical suites. Many of them, in looking for base metals, analysed only for copper, lead, zinc, and maybe a couple of other things. Through our access to representative core from a large number of copper deposits in the northwest, in the Brisbane and Mount Isa core libraries, we are embarking on a program of reanalysis of significant amounts of this core with a full elemental suite to understand as much as we can about what might have been missed, and not just for cobalt, of course. Another area of relatively new interest is that of the circular economy and reprocessing of tailings and other mine waste or stockpiles. Of course, New Century are charging ahead with this idea, but that is an operation targeting the main commodity of the previous mine. Based on the fact that we knew some copper deposits in the northwest could show high cobalt, and that there is a history, though not current, of cobalt production at Mount Isa itself, we wondered if there might be value in highlighting cobalt potential in copper tailings in the Northwest Minerals Province. So here are some of the details of one of our biggest individual projects under the New Economy Minerals Initiative, looking at the prospectivity of mine waste, tailings, stockpiles, waste dumps for new economy minerals and highlighting opportunities for further development. These sites are ideal for exploitation. They are on existing mining leases, infrastructure in some cases already exists, and the resources are above ground. Dr. Anita Parbacker-Fox at the Sustainable Minerals Institute here at the University of Queensland is leading this project and has commenced already by looking at a number of sites across Queensland, both northwest as well as northeast. We started off wanting to know about cobalt potential, but as the project grew, this remit rapidly expanded to include indium, tungsten, rare earths, gallium and germanium. On this slide, you can see on the left the tailings facility at Capricorn Copper, with sampling at Capricorn in the middle and Mount Oxide on the right. Shown here are all the sites that Anita has sampled thus far. She has been kind enough to allow me to include some images and results from a recent presentation that she did for the UQ GSQ webinar series. She's only in the first 6 months of this project with another 4 years to go, so there will be a lot more to add to this list. I'm highlighting here the sites that she is focused on for cobalt, and of course they're all located in the Northwest Minerals Province. However, I will come back to Balgammon here in the northeast a little later. Of these sites, a number showed promising cobalt values as shown in this graph. The most enriched by far is Osborne. Whilst Chenova have calculated copper gold resources on their tailings facilities, I don't think cobalt was included. The average of Anita's sampling for each zone is shown here on the right. Certainly some good averages for the Osborne project and just the sort of opportunity that the GSQ and the SMI are hoping to highlight from this study. Indium is next on the list and is an interesting one to consider. Current indium production is less than 1 kilotonne globally. Even with a projected increase in production of more than 240% in response to low carbon and other technologies, projected global production demand will still be very low. I don't think we'll see any indium-only producers anytime in the near future. However, as a byproduct, it is certainly valuable. Dover Castle, a project near Petford in northeast Queensland within the Herberton mineral field, is a standout for indium. The indium there is associated with tin and zinc mineralisation, with localised indium values reaching over 3,000 grams per tonne, which makes this one of the richest deposits globally for indium. Balgammon is another indium-rich project and currently under the management of the department. It has an historical resource from 2014 or earlier of 2.8 million tonnes at 39 grams per tonne indium, with copper, tin and silver also included in the resource. Individual rock samples from Balgammon run into the hundreds of grams per tonne indium, and indium anomalism is reported in a 20-kilometre long camp extending west of the deposit. Balgammon is the subject of a number of projects sponsored by the GSQ. One is a PhD project through James Cook University, working to understand the deportment and formation of indium-rich ores, and due to access and sample availability using Balgammon as the primary example. Isabel near Cairns will also be included. This project has only just commenced, so we don't have any results to share just yet. Prospectivity of the Balgammon waste rock is another project under our New Economy Minerals Initiative and is part of the broader tailings and waste rock study under Anita's project that I described earlier for cobalt. Anita has collected a number of samples from Balgammon. The image on the top right shows the distribution of samples across the waste rock stockpiles. The image on the bottom shows exposure of the waste rock stockpiles due to disintegration of the plastic cover, which is not ideal, but it does allow sampling of areas that would otherwise be inaccessible. Preliminary results from Anita's study show an average indium value in the waste rock of around 11 grams per tonne, with maximum values exceeding 500 grams per tonne, 500 being the upper detection limit. These stockpiles, of course, contain lots of other interesting goodies with reasonable zinc and tin remaining. The trick for this style of mineralisation will be in the metallurgy, with complex mineralogy playing a major role. And so onto vanadium. This is certainly a developing story for Queensland. Of course, explorers have known for years of the existence of significant vanadium in oil shales near Julia Creek. But now, with the emergent importance of vanadium in low carbon energy technology, work in that region has moved on quite quickly. Multicom, Veco and QEM are just a small number of the companies now active in the Julia Creek Richmond area. The regional resource across all of the published projects back in June 2019 was over 5,000 million tonnes at 0.33% vanadium oxide, with a bit of moly thrown in. I don't doubt that this number has increased significantly since then. However, I haven't had a chance to update the numbers. Again, while we're proud of to promote the development opportunities, there is not a great deal that the survey can add to exploration for vanadium in the Julia Creek area. Nickel is a commodity that we have already covered in brief when I talked about the laterite deposits at Scone and other nearby projects, so I won't belabor this point. Whilst we don't compete with the large-scale nickel production in WA, we definitely have potential. Another PhD project through James Cook University and funded under the New Economy Minerals Initiative will look at the mineralisation potential for ultramafics in the northeast, though focusing less on the laterite deposits and more on any hard rock occurrences. This project has only just commenced, and so no results are available to share just yet. However, the premise for the project is based on a previous JCU honours project, which identified up to 4,000 ppm nickel and 13,000 ppm chromium in samples from ultramafics within the Running River metamorphics. The PhD project will provide a more detailed characterisation of ultramafics throughout the region and will give an improved geological perspective to highlight their mineralisation potential. Silver. Silver is a metal that is experiencing a significant demand push on the back of a solar energy boom. Not only is solar energy being adapted ever more frequently by individuals for their homes, but local and state governments are investing huge amounts in construction of large solar farms to supplement community energy supply. The ACT had a legislated target of 100% renewable energy, renewable electricity by 2020, which is this year, and I believe that they have actually met that target. Industry has also led the way in this regard, with many mine sites now fully reliant on solar power. This has significant implications for silver production. Queensland has a long history of prominence in silver. At one point, Cannington was the largest silver mine in the world and still produces 6% of the world's silver. Silver is also present in significant economic concentrations in sediment-hosted lead-zinc deposits, such as George Fisher, Hilton, Lady Loretta, and New Century. The GSQ's Mine the Core program, with reanalysis of hundreds of poorly analysed or untouched drill core from around the state, will show up any previously identified silver mineralisation. However, I think for the main deposits, this has been well established. And now to rare earths. The government loves them. Donald Trump and Scott Morrison want to partner up on them, and the industry just isn't sure or thinks it's all too hard. Metallurgy can be difficult, and global supply is dominated by China to the point where everything about rare earths has become a political issue rather than an industrial, financial, or a geological one. And from a geological perspective, they are pretty cool. And turns out we have a fair bit of rare earths in Queensland. There is, of course, Mary Kathleen, with an established volume of rare earths in the historical tailings. We also know that rare earths occur in significant concentrations in the IOCG deposits, including Ernest Henry. An example of a formal rare earth plus yttrium resource exists at Milo for GBM Resources, which has advanced historically to scoping study. A relatively new story in the rare earth space is that of the Peaks Range volcanics, held by NorthX in eastern Queensland. Rare earth potential here is hosted in a sequence of rhyolite domes. No drilling has yet taken place, but rock chips reveal up to 0.3% total rare earths. Preliminary volume estimates based on the outcropping domes gives 500 million tonnes, making this a potentially significant region for rare earth exploration. The GSQ is funding a project through the University of Adelaide with Carl Spandler to understand the distribution and evolution of further mineral potential of the Peaks Range area. And lastly, the rare earth potential of Queensland's phosphates is something that I've been interested in for a while. So I'm glad that I now have the opportunity to progress this work as part of the New Economy Minerals Initiative. After all, we have 1,500 million tonnes of phosphorite resource in Queensland along the margins of the Georgina Basin. And the most commonly occurring rare earths are phosphates. So let's have a closer look at that project. The rare earth potential of phosphates will be a project run jointly by the GSQ, led by Matthew Balatich, and by the University of Adelaide, leveraging off Carl Spandler's expertise in understanding unconformity-related rare earth mineralisation. To kick this project off, Matt at the GSQ has been very busy sampling and analysing phosphate to provide a baseline set of information. As you can see in this map, the location of Queensland's phosphate deposits is very much restricted to the margin of the Georgina Basin, which is the pink colour, and all the phosphate occurrences are in green. This is also true of the western edge of the basin in the Northern Territory. We are working with the Northern Territory Geological Survey to expand the coverage of this project as well. Corella is the only one of these phosphate deposits with a defined rare earth resource, giving 7 million tonnes at 930 grams per tonne yttrium oxide, which was determined by Crucible Metals a few years ago. The two big dots in the south, one along strike from Corella, this one here, and this other one over here, are Phosphate Hill and Ardmore. And up here, we also have the Paradise Phosphate Project. I've gone the wrong way. I think this is just about my favourite slide at the moment, and it is one reason why I think this whole package of work is so exciting. Here are our results in blue from one of the Georgina phosphorite deposits. For now, we'll leave them unnamed as we give the company time to digest the results first. This graph shows a comparison between that deposit and the clay-hosted rare earth deposits in China, which are shown in red. Also shown are a number of other deposit types. The Peaks Range and the Toongi deposits are in two different shades of green, and the Nolan's Bore carbonatite is shown in yellow. These results speak for themselves. The Georgina Basin phosphorites have excellent potential for rare earths, not just fertiliser. To further sweeten the deal, this image shows again the Georgina Basin phosphorites on the right in blue, and the comparison is for Toongi and Nolan's Bore on the left. But the main thing to note is the strong results for the really valuable rare earths, such as terbium and dysprosium. So we know that we have some highly prospective zones for rare earths in the Georgina Basin phosphorites. However, rare earth endowment in these phosphorites is variable between deposits, and rare earth incorporation into the phosphorites is complicated. At this early stage in the project, we think that secondary processes may remobilise the rare earths. And some of these rocks are going to be incorporated in the rare earth extraction project, which is being carried out here at UQ as well. So we will understand a little bit more about extraction processes and solutions down the track. Moving down that future demands list, molybdenum is quite easy again for Queensland, though I do admit the GSQ is not specifically chasing this commodity. However, through our Mine the Core program, we aim to identify any and all mineralisation that might have been missed due to incomplete assays. Merlin at Mount Dore is the standout for both moly and rhenium, being the world's highest grade rhenium deposit and not too shabby for molybdenum either. It appears to be unique in the northwest and is considered to be an end member part of the regional IOCG system. Last, but definitely not least, copper. This is a metal that, in spite of its status as a traditional and long-standing commodity, it will nevertheless continue to play a vital role in ongoing technology advancements and the electrical economy. 0.38 million tonnes of copper was produced in Queensland in the financial year 2017 to 2018, and nearly 94,000 square kilometres of granted exploration tenure covers the northwest, making up a third of the minerals province. The Geological Survey has been a long supporter of copper exploration in the northwest, with our previous and still ongoing funding package, the Strategic Resources Exploration Program, delivering $27 million worth of programs to boost and support base metal exploration in the Northwest Minerals Province. Of course, none of this fantastic work being done by members of the GSQ and our collaborators is any use to anyone if nobody knows about it. We won't find the next big deposit in the Northwest or the Northeast by sitting in our offices here in Brisbane and telling ourselves what a great job we've done. So starting in 2018, continuing all through the last year and this one, we have made a commitment to take our work, our results, our data sets and ourselves out into the areas where they can be put to the best use. We ran 4 workshops last year aimed specifically at mineral explorers in regional mining centres such as Mount Isa and the Northeast. Researchers at the Sustainable Minerals Institute, Rick Valenta, Paul Gow, Nathan Fox and others have been a huge part of those workshops. And for that, I thank them very, very sincerely. This year, we have, of course, had to take that program online. And since April, we have been running a weekly webinar series in collaboration with UQ, again with Rick Valenta and team at the forefront of that effort. You can find the website for the schedule and the registration links here. Of course, you will see that it's an SMI website, so evidence of that really strong collaboration. We want to be connecting with the people who are doing the work, have their boots on the ground and are the ones actually designing drilling programs, soil sampling grids, and will be the ones who make the discoveries that we all want. The workshops and webinars have been very successful, with in-person workshops all being fully booked and some of our webinar attendees reaching over 200. The greatest measure of success for me, however, is that we have explorers actively interacting with our data, taking it home and overlaying it on their own internal data sets. So I'm going to leave it there. Critical minerals are a niche group of commodities, but they are essential for our technology-driven future. Now that I have introduced you to our approach under the New Economy Minerals Initiative, I hope to join with you again, perhaps in another 12 months, to share some of the results of our program, as it has only just kicked off this year. And I also want to share at that time and ongoing my personal excitement for this frontier part of the minerals industry, which is seeing such rapid evolution across the sector. So thank you very much.
Thank you very much, Helen. That was a really fascinating insight into the initiatives that have been carried out by GSQ and obviously your collaborative partners. So that's great. We have got a few questions coming in online. Helen, I don't know whether if you have a moment, if you wanted to have a quick scan through, there's just a couple there to start with. Probably the first one that came in was from John Lorraine, who just wanted to talk probably more about the downstream aspect of some of the initiatives. So the exploration and mining of these commodities are very significant, but in terms of kind of more forward kind of thinking and value add, are you aware of any initiatives that the government are taking to actually improve refining of these commodities and also the marketing of those products as well? So they're kind of, I suppose, keeping them onshore as well.
Sure. So the first part of the question, I guess, is to do with extraction and refining. So we, as I explained, we have a big project led by Rick and Paul Gow, Gordon Southam, and a number of others within the UQ, looking specifically at extraction of rare earths, knowing that that is a problem for that part of the sector. It's historically been quite expensive and also quite toxic for the environment. So they're doing some really great work using hydrometallurgy, phytomining, and the use of bacteria as well. There's also a lot of initiatives going on at a federal and state level, looking at the concept of precincts and hubs for processing and manufacturing. So the aim there is to try and develop a more sophisticated and advanced and own more of the supply chain within Australia, I suppose, because overseas countries do have such a dominance of the more downstream value add components of the industry. The Critical Minerals Facilitation Office is driving part of this. That's the new federal body that was set up in January down in Canberra, and they're working on precincts for different commodities in all of the various states. And the one in Queensland, we sort of proposed that perhaps we'd look at cobalt, because that's an area where we're more advanced and have the greatest strength. We certainly can't compete with WA, for example, for rare earths or lithium. They're a lot further down the line than us.
Sure.
And then in terms of, there was a component of that on marketing as well. So Trade and Investment Queensland to have a very active presence overseas. They have offices in a lot of countries overseas to actively market resources and our products over there. And the GSQ does take an active role in that, promoting opportunities not only for the exploration side, but investment in more advanced projects as well. That's been a little bit curtailed this year, but obviously we're sort of moving that online and exploring other options.
Okay, excellent. That's good. That's great answer. There's another question here in a kind of similar way from Isabella Garbus. I hope I've pronounced her name correctly. Again, looking at the interaction with, I suppose, either METS companies or other companies that are going to help crack the metallurgy. So the metallurgical challenges obviously seem to be one of the major things that are being highlighted with some of these, particularly some of these cobalt deposits having particularly low grades. Obviously they're economic, but the metallurgy may be the thing that actually defines some of the economics. So Isabella's question is just looking at the complex mineralogy from Balgammon and more broadly across the mine tailings and waste dumps. How can the government, state or federal, look to support programs that may specifically target the businesses trying to crack the metallurgy? So I guess this was, yeah.
So Anita's project on the tailings and waste dumps, so at the moment she's just 6 months into that project, but it is expanding over the next 4 years. And one of the ultimate aims of that project is to define potential processing pathways. So she'll be looking very much at the mineralogy and metallurgical solutions for each of the case study that she's got going. So that will include Balgammon. And then in the cases where those deposits or those sites are currently held by a company, she is working very closely with those companies. And the idea obviously is that we don't do the work for them. We develop a certain baseline and then it's up to the company to commercialise or take advantage of that. Balgammon in particular is currently held by the department, but our preference would always be to re-commercialise sites so that they're not sitting idle, generating environmental waste and costing the taxpayer a lot of money. And reprocessing of tailings is a great way to remove some of that environmental legacy. So being able to understand more about the tailings at Balgammon and other places is a strong step towards being able to re-commercialise those projects.
Excellent, thank you. So the next question from Eric Conahan. Just wondering if you could comment on the rare earth potential of the Elaine Dorothy copper gold deposit near Mary Kathleen.
I couldn't tell you the exact grades off the top of my head, but I know that there is some rare earth potential there, and Hammer Metals, who own the exploration tenure in that region, are certainly actively looking for rare earths, and I think they've made a few ASX announcements about some of those results in the last 12 months or so. So yeah, there's definitely potential for rare earths around there.
From your experience of being an exploration geologist in Queensland previously, do you find that new companies now are actually embracing that kind of multi-element exploration approach? Are you seeing more favourable prospects coming just from that change in analytical protocol?
Absolutely. I think, I mean, even before rare earths sort of became politically popular, the expanded suite of elements was certainly more standard practice than it had been previously, sort of in the last 10 to 20 years. So if there was rare earth endowment, they would at least have picked up the lanthanum and cerium and perhaps the yttrium, even if they weren't analysing the full suite. But definitely now companies see that's a point to be able to make to, as an add-on or potential sweetener for the deal. So a lot of companies are reanalyzing their own samples, and then we're reanalyzing the ones that we hold in our stores to try and improve that data set and that baseline.
Excellent. That's good to see. Just one more question online from Stuart Parker, commenting obviously an excellent talk, so it's obviously very appreciated. Just questioning whether there's any further opportunity to include other properties in the current processing and extraction studies at UQ. He comments that he's obviously interested in the peaks, rare earth, niobium, zirconium, hafnium property, but again highlighting that the processing and extraction paths are going to be critical to the success of these properties.
For sure. Look, Paul Gow and Rick would be the ones to talk to. I guess in that, because now I can't remember off the top of my head which sites I know we were looking at the ones in the northwest, but the peralkaline volcanic suite of rare earth projects is definitely an entire other class that would be great to capture in that extraction project. And
we'd certainly plan to do that as well. We were going to certainly have a look at them.
So no doubt they'll be in touch.
Lots of exciting work to go, I think. Well, I'm just going through the list of questions online. I think we have pretty much covered all of those. Unless, Rick, you had any other questions or comments. And I noticed, Neville, down in the seminar room, I guess there's no questions from the floor down there. If there were any questions, if anybody wanted to come and approach the microphone to ask Helen directly, that'd be great.
The only thing I was going to mention, Helen, is that that the diagram of future demand that you showed before, and you said, "Oh, I'm not sure where that came from." It's from the Visual Capitalist. So if
perfect. Thank you. I'll make sure I can put that.
If somebody does a search for Visual Capitalist new critical minerals or new future mineral supply or something like that, then or carbon, if you search a Visual Capitalist, you'll find it.
Thank you.
Okay, well, if we haven't got any more questions, I think, Helen, I'd just like to thank you once again for your talk. That was really excellent and really stimulating. It's great to see such a lot of growth going on in Queensland, and the support for support particularly for UQ, but all the other universities in Australia. It's good to be working in a collaborative environment. UQ
is definitely our major collaborator in this program, so good.
We'll look forward to it. I just wanted to say, well, obviously, thank you again, and just to announce that next week is the final seminar in this semester, and that's going to be from Claire Coate from the SMI, who will be talking about new legislations on progressive rehabilitation and closure planning and practices. So we look forward to welcoming Claire next week. But for now, I guess I'd like to say thanks again, and thank you everybody online for joining us, and hopefully speak to you and see you next week. Thank you again.
Thanks, everybody.
On.